What's going on, everybody? We are back live and direct right here on Building Stuff with Nova. Now, we're in the new studio, as you can normally see whenever we're not in our home base. But I want to make sure that you all can hear me. I see that we are now live, not just on Twitch. You know we're normally live on Twitch. But welcome our Nova YouTube family. If you all can hear me loud and clear, I need to know in the chat. Say hear you loud and clear, ready to go, because today we have another special edition of Building Stuff with Nova. This is our virtual makerspace, and you're going to see even more of that today. This is our mastermind. This is our ideation laboratory, the place where you and me, Dr. Nee is what I go by, we can build together. As a matter of fact, it's not just going to be you and me. It's going to be you, me, and our special guest that I will be introducing here in a little bit. But let me take a note and just see. Shout out to Outbound. We see Outbound. You can hear me well on Twitch. We got that Opal guy. Yes, I'm super excited. Now, let's do something real quick because, again, we are in a virtual makerspace, and we're going to get busy because we have something to build today. You see in the chat, it is a robotic arm. We're going to get a quick overhead shot really quick. Joe, give us a nice overhead shot so people can see. We got it nice and laid out. Our makerspace nice and laid out. You see our guest right there. Coming back to me, I'm going to tell y'all, here's our agenda for today. All right, here's our agenda. Right here on beside of me, you can see I'm going to introduce our guest, Rich Gilliam, in just a second. We're going to get to building this robotic arm. Now, it's not going to be the Winter Soldier type arm, that Opal guy. I saw the comment. We're not going to do that. But it's going to be a robotic arm that, you know, you all can perhaps do one day in the future on your own. But without further ado, let me go ahead and bring up our guest for today. Rich Gilliam is our guest. He is a TEDx speaker. He's an award-winning author. He's a STEM professional, an automation engineer to be exact. He is the founder of STEMplug, which aims to develop minds into becoming leaders and innovators of tomorrow. The end goal is to use STEM to enhance both the professional and social development, in addition to increasing employment opportunities. Rich's current vision, and you're going to hear a little bit more as we chat, is to author an international best-selling children's book titled Diverse in STEM. So, without further ado, let's go ahead and get our friend Rich Gilliam on the screen today. Rich, how you doing, man? How you feeling?
What's going on, bro? Appreciate you having me, bro.
I appreciate you being here as well. For this has been a thing in the making for a couple of weeks, and we're gonna get busy. And before I even ask you a question about yourself, what are we about to build? What are we about to build here today?
All right, man. So what we're about to build today is we're going to build a robotic arm.
Yeah.
Not only just a robotic arm, a hydraulic robotic arm.
Hydraulic powered robotic arm. Okay.
Yeah. So this robot works strictly off of water. So when you think of hydraulics, you know, the water acts as fluid that really acts as a mechanical to kind of get the arm up and moving.
Hydraulics is gonna be water powered. Okay.
Yeah. Yep. So we're gonna have fun with this this build here.
All right, let's not delay because we got a lot to build. Chad, we got a lot to build today. If y'all are excited about this, I hope you are. We got a lot to do. Extra points for pneumatic. Yes. A Clockwork says they love the fact that it's hydraulics involved in this. Got it? Rich Novate, what's up? Someone showing you some love in the chat. All right, talk to us what we got here. We got a nice overhead shot ready to go.
For sure.
As you all saw earlier. But what am I gonna build and what are you gonna build? Where are we starting at today?
So we got our manuals over here. Me and you both got our manuals.
Yeah.
So I'm gonna over here and start with assembling our clamp.
You're gonna do the clamp? So like this part right here?
Yep. The clamp.
This is the clamp. The clamp is used for actually.
So that's the gripper. That's what's gonna kind of like pick up different things.
All right, cool.
And then you're going to work on assembling our arm. So the way that this build works, there's different sections pretty much that you can kind of build and sequel with each other. So it's great for collaboration like me and you are doing right now. We're collaborating with each other to build this robot because this, you know, we see an end product, but this definitely takes some time to build.
Yeah, let's do it. Let's do it. And I don't even want to delay. Like everyone, I'm going to get the vibes going here in just a second. Shout out to Future Doctors, the overhead lights a little bit. Okay, you don't see us well overhead. We're going to try to make sure we can get it as visible as possible. I'm going to get some vibes going here as we work and build together in our virtual makerspace. Hello, Rich, says Opal guy.
Okay.
Let's see.
Let's get it.
I'm going to get this arm going.
And I did the due diligence of cutting up all the parts.
You did.
This, with any engineering, science, building, everything, there's a lot of preparation that goes into different things. So before you can even get to building, right?
For sure.
That prep work can be a lot. So
yeah. So you basically had to go through a whole project just so we can prepare to do this project.
Basically,
project for the project, plan for the plan. No, I love it.
Plan
I love
for
it.
the plan, bro.
And I don't want to lose anything, Rich, because I see that every piece, at least that you've organized, matters. So I'm gonna pay close attention.
Yeah, and I tried to label them with the letters and everything like that, so we can kind of see from there. But
Yeah.
Let's get to it.
All right. So let me ask you this. So you are, and by the way, chat, I'm gonna show y'all this really quick. Let me show y'all the front part of this. This is what we're building. These are the pieces. And we have a nice completed version over here, right? That's what we're working on, a nice completed version. But Rich, you are, as I said in the intro, also a STEM educator. You are author and all of that, which we'll get into in a second. But your technical area of expertise is automation engineering, right?
Yeah.
So
I've been working in automation engineering, robotics specifically for the past about 5 years. Yeah.
So what is that? What is an automation engineer exactly?
Man, an automation engineer, I would really say is really a jack of all trades, right? Everything from, dealing with understanding the science that, might be ran within the robotics to, building robots as well, working on, a lot of the things that I do is building work cells of robots that kind of like work in sequence with each other. So that really takes a lot of time of like understanding how different robots and automations kind of work with each other in sequel.
So like kind of like what we're doing now with this robotic arm, you get a lot of different robotic, I guess, members of a team, so to speak, and get them to work together.
Yeah. I mean, you can pretty much say that in like my current like robotics role that I work in is really just understanding that pinpoint of like certain robots can do certain tasks, right? So understanding, what do I want to what is our end goal here, right? So even here as we're building this hydraulic arm, right?
Yeah.
What is our end goal that we're looking to really build? So,
man, I'm trying to figure this out now too. So this is the arm. This is the arm, and then I connect that to here. And I'm looking at the instructions too. It seems like the instructions, each step has like a large number of components, even within that one step.
Yeah, bro. This is an intense build.
It's an intense build because you don't necessarily build all of the things. Well, do you build the stuff that you work with on the job, like in your lab?
I mean, it's I would say it's two hands to it, right? Like a lot of our robots that I kind of support, they may be already like the vendor may come in and like already set up the robot because it might be from a certain specific manufacturer. But
they don't want you to mess up their work.
Once we're in the lab and we're kind of like building for like maybe like the assays and experiments that we're building, then that's when you kind of just have fun in the playground, what I like to say. So really just taking those different robots and like when I say a work cell is like robots in an area that are all working in sequence with each other. So taking all those robots and now building them together to work in sequence with each other.
So a work cell is like a terminology that you all give to like a certain part of the automation flow.
So you could think of a work cell like say you have a large experiment and you could say a work cell is pretty much like it's going to perform a certain task within that experiment. Yeah.
Got you. Shout out to everybody. What up, Papa Sim? We see Papa Sim out there. I see Opal Guy on YouTube is asking, is there a link for this? Now, this is unreleased right now, right? We got a little early hand.
They can check it out on Kickstarter.
Okay, this is a Kickstarter. All right.
Still pre-order on Kickstarter, but the release to this won't be until January. So this is like people are getting a first-hand look.
Yeah, we're getting an early look into it. Yeah. So I'm gonna focus here a little bit, and y'all know when we get building, y'all know when we build on this, right? We have a lot of like downtime because we get it rocking. I have, let me see, the vibes are coming just a little bit. Can y'all hear the vibes? Yep. Automation and factory simulator. Oh, that's a good question. Someone asked, a Clockwork asked, have you seen the new automation and factory simulator, Satisfactory? It's like a game. We do a lot of games on this show. Have you seen Satisfactory at all?
I haven't.
Yeah, there's a game we played. We played Factorial. We actually, in chat, y'all remember this, especially the building committee on Twitch remember this, but we voted. We were trying to get into a little bit of industrial engineering.
Okay.
And so we voted on the games to play that were more like factory based, and we did a game called Factorial. But Satisfactory was another game we were considering at the time. And there are a lot of games. Like, are there any games that you have played or you've heard about, just in terms of like the work you do and that relates or correlates to that work?
You might be talking about a future product there. I haven't. I love to see a game like that, but it is one. I'm trying to remember this. There's a I forgot the name of it, but there's like some program that has like virtual, like simulated lab experiences.
Oh, we did a thing called Labster.
Yeah, I seen Lab. Is it Labster? I don't think it's Labster.
You don't think it's Labster?
But yeah.
All right. By the way,
Trying to remember how that.
chat, you've already seen in the chat our Nightbot friend, particularly over on Twitch, right? We're dropping a survey. Now, there's a survey where we want you all to take a moment to fill out, just give us feedback on your experience. Give us feedback on the experience you've had with this Building Stuff with Nova show. This is supported by the National Science Foundation, so there's research involved in it. And this research is all about trying to identify how informal STEM learning takes place, let's say outside of the classroom, even through media and other non-traditional means. So if you are interested in continuing, to have this experience and have Nova have these opportunities, we want to get the insight. We want to get the insight so that not only Nova can do it, but the research can help inform other types of outreach in STEM learning like this. Right, Rich?
Nah, for sure, man. That's what it's all about.
That's what's,
really understanding how we can, continue to build and have fun and related to, everyday life, right? So, even with when we think about a hydraulic robotic arm, right? I think of things in today, like, my audience that I really like to cater to is really elementary school kids, right? Before they get to middle school, when they're like so impressionable and they can really take on different things. And as I think of a hydraulic robotic arm, I think of something like, we're seeing all these hurricanes going on, right? So a hydraulic robotic arm can be something that can be used to really, help clean up communities, different things like that. So for kids to be able to get hands-on experience of an arm like this at a young age and really just kind of have fun with it, it can kind of give them those real life aspects as well.
Got you. You how did you get into this though? Did you go to school to do automation engineering? Tell that story, because I know a little bit about it. And by the way, before I keep going, I feel like I'm missing something. In my arm. Like, is this all the things I need for my arm? Because I don't see that. I don't see that piece right there on the bottom. Or maybe that's at the top. Maybe that's supposed to be.
I think you got it.
You think I got everything?
It was a bag. Did it come in a
Yeah, this one right here.
Okay.
So I got everything.
You might have. Did you finish it?
I guess it just looks different. It looks different on the.
What page are you on? You're on.
I'm right here, on the arm. I'm gonna see that on page.
Let's see.
Thank you, Clockwork. Releasing the kit. Yeah, Clockwork says, I love that he's releasing the kit. This arm is, I got one a few years ago and built with a son out of wood.
And I failed to mention, I didn't mention this part, but the kit actually goes with my next book, Robotic Adventures. So a character named Richie who uses robots to really help him clean up a city. So the book will have kind of like, activities that kind of go with the kit, and people can kind of build along with. Got it.
And we're gonna have plenty of time to talk about. I want to make sure I get some progress.
You talk about the we
we gotta make sure. I've done a number of like builds on this show, and some get further along than others. I'm gonna be honest about that. This is up top.
So you haven't completed all your builds on every show? That hasn't been fully completed?
Rich, I would like to say yes.
Okay.
But the answer is not yes. No, I definitely am missing. I'm missing some, cause look, I'm looking at this part right here. This here.
Yeah.
And this looks different than this part.
You see the number? The number should be on the
so that's F1.
Number.
I don't see F2. That's what it is. I don't see F2. This is F2.
That might be one of the miscellaneous parts.
All right, so we got F2.
That I was mentioning.
All right, here it's F, right here. It's right here. So there we go. I was like, man, something doesn't look right. All right, so F1, F2. No, you good. But yeah, in a second, I know you're trying to figure out yours. When you get back to it, I want to hear you tell me how you got into this work.
Oh yeah, how did I get into robotics?
Yeah. Let's see here.
Really, I would say it found me.
Robotic? Because you didn't go to school to study this, right?
Well, I studied biology.
You studied biology. Chad, he studied biology and got into robots.
Yeah.
He might have the combination of skills that they have in those movies, right? Biology and robots.
Yeah. So I studied biology, and I was a scientist for some years.
Okay.
And one of my roles that I was in as a scientist, I was actually doing.
There we go. Boom.
One of my roles I was doing as a scientist, I was actually running experiments like on automation robots. And I kind of got to a point where like I don't know. I just got to the point where I'm like I go through this a lot in my life where like I feel like I just want to explore something different. So I kind of got to a point where like I was like, okay, I want to really explore the engineering side of these robotics, right?
So let me go back. You were doing experiments in biology, but you were using the robots like this. Is that what you're saying?
Yeah, pretty much.
Okay.
Yeah. So the same robots that I pretty much work on today in automation, I was that like scientist that was like running experiments on them pretty much.
And can you share what type? I mean, I know you probably can't share actual confidential stuff, but what type of experiments, biology related experiments, would something like this be involved in?
For sure. So I mean, some of the things that I worked on was like a lot of different like I would say genomic testing. Like so we'll have like different I work with everything from saliva samples to blood samples, and then you'll have pretty much a robot that will be able to, imagine getting a full batch of a bunch of patient samples of like saliva or blood samples. Yeah. And then we have now robots that can pretty much aliquot those samples. And once you aliquot those samples.
What does aliquot mean?
Sorry, yeah.
Using a terminology. Using the terminology.
My bad, bro. So aliquot is pretty much like taking a part of that sample. So imagine you get in the sample pretty much, and then you don't want to use the whole entire sample because maybe the robot might make an error or something like that. So now you're able to aliquot and take a specific part of that sample and then kind of go to the next.
So y'all had robots doing that.
Yeah.
By the way, so this is what we got going on. Cyborgs. He has a small. Yes, absolutely. We put our builds in ICU, a clockwork. I'm gonna show this real quick. Y'all can see this. This is the box that we're working on. I'm gonna keep it here in the shot. And then here in the back, it's the finished product. Just a finished product of what we're working on for those who didn't catch that. But this is where we are. And Rich, the automation engineer here, former biologist, you went to school for biology, and then you were doing this work in biology using robots. And then something said why don't I dive deeper into the engineering behind it? What makes you feel like you as a scientist could even understand? I'm not gonna say understand because obviously you're intelligent, but I mean like, what gave you sort of like, I don't know, just the confidence of saying, all right, I'm about to become a tech person, even though I started off in this natural science arena?
I mean, honestly, bro, it was just like, it kind of all just started from just taking initiative when I was like in that scientist role, right? So when like the vendor of the when the vendor would kind of come in and maybe work on the robots, when I was a scientist, I would kind of like become that key person of like just like understanding the you know, the fixes that he might make and things like that.
Yeah.
And then I just kind of took that experience and then just, you know, I got a opportunity you know, to kind of like dive in more in a like an entry level type role in the engineering, and then I kind of just build from there.
You start building from there.
Yeah.
Gotcha. Chat, feel free to ask questions as we go along. I'm gonna lock in here in just a little bit because I think I'm starting to make some sense of the arm here.
Yeah, no,
especially as I look at the way that a lot of this stuff is supposed to be situated.
Mm-hmm.
Let's see. So this is gonna come here, G6. Boom.
Yeah, you got it. Yeah, but nah, I mean that's kind of like I've always had like I get to a certain time point where like I you know want to kind of like I don't know, just try something new, but also use all my skills that I already had. So like even though I say I'm a an engineer, you know, all of my experience that I had in biology and in science
comes in handy.
Comes in handy in that
utilize those, yeah.
Yeah. So.
But you went to school for biology at an HBCU, right?
The AUG.
Tell the audience what the AUG is. Everybody don't know what it is, man. We out here with Nova. What's the AUG?
St. Augustine's University.
St. Augustine University, and that is an HBCU.
Yep.
Down south, and you're not from down south. You're from.
I am not.
Where you
I'm from Philly.
Let them know. Yeah. Philly in the house. Anybody from Philly?
215.
Anybody from Philly? We got a Philly guest today, y'all.
Yeah, I'm from Philly, bro. But I love North Carolina though.
You love North Carolina? Okay.
Yep. Mm-hmm.
Me too, man. Me too. Let's see. I am coming along here. This here is a part of F5. Here we go. This is my F5 piece. So all these joints right here, man. Mm-hmm. I'm looking at this look. So this arm has a joint here. Mm-hmm. There's a joint here. When you're designing like a robot or some piece of device to do whatever you need to do, whether it's aliquot. Shout out to a Clockwork that dropped the definition on Twitch.
Oh, thank you, Clockwork.
Yeah, Clockwork dropped that. Do you think that like you need to always be mindful? Like, is this part of the design, right? Like when you're setting things up, thinking about how many joints you need based on the way that it goes. Like, how do you think about that? What's sort of the thought process?
Yeah, no, for sure. Yeah, I would definitely say like, you know, with anything in designing and building, you definitely have to have those, you know, those thoughts of like, you know, how the joints are pretty much like set in the robotic arm, because it, you know, it can also have tension if you don't have the correct amount of joints, or if you're not pretty much building that in that right flow. Mm-hmm. So that all kind of comes into play.
And do you think about it like you're thinking about your actual arm? Like you look at whenever you're saying, all right, cool, I want to get something that does this or whatever. Like, are you looking at your elbow, your fingers? Like, that's what's going on?
Yeah. I mean, even right now, right? You're building that robotic arm, and the instructions that it's kind of giving you is that you have to build the joint in a certain angular motion, right?
Right.
So if that joint is not in the correct angular motion, it might look fine, like, but once we get to the point where we want the arm to actually work, it might not even move at all because the joints aren't properly flowing, right?
So, for instance, like, what would it look like here if something was like, what's like a simple mistake a person could make with this joint wise?
What's a simple mistake?
And do you all ever make mistakes where you're like, oh, this thing?
I make mistakes all the time, okay. But I learn from my mistakes. I mean, I've worked in R&D for the past 5 years of my life, so you learn from your mistakes. But yeah, I mean, I would say, you know, something that can kind of be off here is really within the inside mechanism of this, right? So within the inside mechanism of this, you know, there may be you might have the wrong, I would say, So if you go back to the one that you had, pretty much.
Right. So here.
Yeah.
I'm making progress here with my joint.
Yeah, where you built this. So one of the things that can kind of be easily mistaken is mixing up these parts, like this part right there and that part that you have over there.
Mm-hmm.
You can kind of get those mixed up.
Okay.
And if those parts are kind of mixed up, like I said, your arm won't move. That tension that you just had for it moving, you probably wouldn't have that same correct movement.
Right.
Yeah.
I can tell, by the way, chat, if you get a hold of some of this, right, you will see how it's obviously like a lot of circular things involved, right? When you're trying to position the joints where they need to be. But I feel like, Rich, they're probably like, are there advancements in how certain joints can go? Like, I'm sure they're like ball joints and like other types, maybe not terminology wise. And maybe Nova, shout out to Nova.
Yeah.
You all can give us some.
Yeah,
give us some terminology on
some
this.
terminology.
But what I'm saying is like, there are different types of joints, right? What are other ones descriptively that you can see? Because these are like very kind of like up down kind of related.
Yeah. So I mean, it kind of all depends on like the type of robot that you're building, right? So as we're building this particular robot, those up and down kind of joints that we have, it kind of relates more to that robot. But you might have a more if you have a bigger robot, you know, compared to this robot, then of course those joints are going to be like in a different angle or different motion. So there it goes.
Clockwork says, when I did projects like this with my elementary school son and daughter, the main goal is to have all the pieces for the next step organized and available. No, that's smart.
I know that.
And Rich kind of did a little bit of that for today's stream.
If we didn't have that, we would have,
Oh, if we just cracked this open, Rich, it would have been.
Yeah, it took me 4 hours just to get all these
pieces together.
Yeah. So
where did the vision for the robotic arm come from? Because now I want to get a little bit, I guess, into your educational work. Were you like, all right, I'm going to create something that's similar to the work I do on a daily basis? Is that where?
Yeah, I mean, I can say that, and also I would just say, as far as like, you know, really just trying to. My goal that I always had with like my you know, everything that I kind of like build and put out is you know, making STEM fun, but also really helping kids related to everyday life.
Okay.
Right. So I just felt that this robot can be a way where, you know, it can be something tangible that kids can build, but it can also be something where kids can really see that direct correlation of how it can be used in everyday life. So, but yeah,
I don't know if I had a robotic arm at the crib, I promise you I would use it in everyday life.
Yeah.
But I mean, break that down though. What do you mean?
But I mean, I look at something like this as well. Like a child can imagine all the parents on the chat. Imagine you telling your child, "Hey, go clean your room." They can use this robotic arm to maybe pick up some stuff off the floor or some of their toys or something like that. You know. So and then not only are they being obedient, but they're also kind of learning. So, but
is that something you feel like you were a child like that?
Nah, not at all. Nah, bro, my story has been a journey. I was not into STEM when I was growing up. Yeah, I got into STEM pretty late actually, like not until I was like my 12th grade year. So, but
sup Airplane. We see you, Airplane, in the chat. Shout out to you.
Yeah, this thing is.
Thank you so much, Nova, for dropping out the different types of joints. You got hinges, ball and socket, all provide different range of motors to serve different purposes. As Rich said, shout out to Nova for giving us that insight.
Yeah, thank you,
Nova,
Airplane. For the bars.
If you're brand new to this, y'all, this is a good time on Twitch to hit the follow button, to go ahead and follow us. We're continuing to grow on that platform. And if you are on YouTube, come over to Twitch, follow us. But we need you all to mark on your calendars our finale. Nova, let's let them know about our finale. We actually have a phenomenal 4-part engineering themed escape room that is coming up to be our finale of the Building Stuff with Nova show. So that being said, I think you all need to keep that in mind. As a matter of fact, Rich, did you know that we were doing Did you know that we were doing an escape room?
Nah, I
You
didn't.
did?
That's
Oh
tough,
man,
though.
Noah gotta let people know
tough.
about it. So
Yeah, no, gotta let us know.
So
That's
I'm gonna tell Rich about it, and chat. You all can definitely hear about this as I tell Rich about it. But here's what we're doing as a finale. So we partner with a company out of Boston called Trapology Boston, and they are I like to refer to them as escape room gurus.
Wow.
Escape room gurus, right? And we have designed, not just by ourselves, not just with Trapology, but with chat, with everybody in the chat. Shout out to people who were part of those ideation sessions. We have designed, Rich, 4 days of puzzles as an escape room. Have you've been to a regular escape room before, right?
Yeah, for sure.
Yeah, so we got 4 days of puzzles that are all around the theme of different engineering concepts, right? And so we're gonna have a team of folks in real life in Boston with us, going through the puzzles, trying to help solve it. We're gonna also have chat on Twitch. Shout out to everybody on Twitch, everybody with us live, solving these puzzles with them. And there's gonna be this nice little like Y3K theme about it.
That's tough.
So Y3K, you know, Y2K was year 2000, but Y3K, we have this whole narrative of where the world has become super dependent. And you all check this out if y'all remember this, super dependent upon AI. You see AI is already rising right now. It's only 2024, Rich. But we're imagining that right before the world or time becomes Y3K, we're so dependent that now there's a need for us to sort of update. I think that's the term we're using it, but basically retrain the algorithm on different engineering principles. And so that is sort of the narrative around our engineering escape room that we came up with. We came up with chat, actually.
Nah, that's hard. Oh, so your audience kind of came up with that idea to do that.
Yeah, we did it with chat. We did it with
Voice of the
everybody
people.
in here.
That's what's up.
Yeah, shout out to again Nova for this awesome project, and shout out to everybody else a part of that.
It's a great community. Yeah.
That idea, that ideation process. I think I'm almost done with the arm too, by the way.
Yeah, you killing it, bro.
How's your gripper coming?
It's going pretty well. I'm trying to this one piece right here that I have, this mechanism, just trying to straight. And that's kind of, you know, another thing when we're talking about like building the arm and building, you know, this gripper. A lot of times you have to there's trial and error with different things, and you realize you might put something together and you're like, okay, yeah, I don't think this is the right way that this is kind of supposed to go. So
that's all about the engineering design process right there, man.
yeah, there you go. Yeah, that engineering design and those systems on how you're kind of putting everything all together.
For sure. Let's see. So we got a question for you in the chat, Rich, from a Clockwork over on Twitch. What's your favorite work tool? Like when it comes to things that are like your go-to, gotta have it ready to go. I see you gave us some of these little clippers here.
Hey, I ain't gonna lie. Right now, those clippers are.
Y'all see that, chat? This is the favorite tool right here.
And I'm gonna tell you something. Like, so with this build, I actually didn't have those clippers, unfortunately. I was using some scissors,
Okay.
and that made the process like so worse. But you know, my favorite tool. That's a good one. Favorite tool.
This is coming along well, y'all.
Dang, I don't want to.
That's a good question.
I don't want to just say my mind. But
hey, you gotta use your mind for sure.
Yeah.
Do you have to use like a lot of pliers and like screwdrivers or anything, or?
Yeah, I mean everything. You know, all different types of tools. Allen wrenches, pliers.
Yeah.
You know, and sometimes different tools can work for the same thing, I would say. But yeah, I know in the lab I work in, we have all different types of tools from, you know, wrenches to pliers to, you know, a lot of cutters.
Yeah, I cut like metal and stuff.
Yeah. I mean, a lot of projects that I've been working on recently is actually like building frameworks to like actually like set up cameras to watch our robots for testing. So
y'all got like a whole little studio, kind of like this.
Oh yeah, it's crazy. Yeah.
But
with that being said, that's like kind of like putting together like different mounts, but having to be creative with it of like, okay, how can I put together this mount for this robot where the camera won't obstruct like when the robotic arm is moving and stuff like that. So that kind of goes back to that, like that systematic thinking of like, and trial and error of like testing things out of like, okay, how does this work before people are actually like running things in this work area.
Because I guess it can be dangerous too, right? Like if something is handling, I don't know, something combustible or something, I don't know, fragile or even not even dangerous, but something that is like expensive. It's like, yo, we cannot destroy too many of these little whatever samples, right?
Yeah.
And if someone designed one of these, chat, for like the handling some expensive piece of, you know, sample or whatever, and it messes up, like that's a pretty serious offense.
Yeah. Nah, for sure. I mean, that kind of tells a story of like what R&D is though, right? Of like testing out things before it's like actually going into production. So that's a lot of like what my roles have entitled over the past like 5 years of I always like to say kind of like playing a video game before it's actually on the market. So that's what I do.
Yeah. I've played a lot of video games on this channel as well. Earlier this week we played
I'm gonna go ahead.
What did we play this week? We played Spider-Man Miles Morales, which was a pretty fun game.
Oh, okay.
Look, y'all, we getting busy here, y'all. We getting busy. I'm getting the little bottom part. This is what we're doing. Again, for the new people, remind them that this is going to be a robotic arm, but the power or the strength from this power arm comes from from water.
Yep. So we got down here. We have the joysticks pretty much. So these joysticks are going to pretty much control how the robotic arm is going to move. So the water acts as a mechanism, as the mechanic to pretty much control all the joints and everything of the arm.
All right, y'all can see that. Y'all can see that. I'm trying to get it in the shot. I know we don't have a roaming camera right now, but we're gonna try to see if we can get it in the shot. These are the joysticks here. All right. And this is the water. This is like the water reservoir, right? For the hydraulic pressure.
That's what I'm about to film.
So you about to do that now? You about to do that now? Okay. All right. I'm gonna set this back down. We'll zoom back out.
Okay.
And you're about to do this part for our current.
A cup of water.
Let's see. Let's get a cup of water ready to go here. As I'm working on the base.
It's magic.
Yep. We got a hand coming in. Thanks, Joe. Yeah. Shout out to Joe behind the camera. Y'all give a shout out to Joe. Clockwork has definitely asked some great questions. Let's see if there's another one. Rich, what kinds of sensors do your robots have? And what are your favorite types of sensors? That's another question that came your way. Are there sensors involved?
Yeah. So like, I guess to ask in the chat, are we talking about like what sensors kind of detects the fluid or
any type of sensors? Because we don't really know. But what are you detecting, period, with sensors?
Yeah. So, I mean, when you think of sensors, you have a lot of different sensors. Like sensors can detect fluid. It can detect, how much, even a sensor detecting if something is overheating or something like that. Fluids can, I would say, I mean, when you think of a sensor is really that thing that really controls your mechanism to see if maybe something is going bad, right? I know in the lab that I work in, having certain like for example, like we might have a robotic head that has a core head that has different sensors in the channels that might pipette up and down for a sample. So you have sensors that can maybe detect, oh, this sensor is kind of going off now, so the fluid won't be detected once the core head or the pipette head is like kind of like pipetting everything.
It's not where it's supposed to be, or like it's just not in motion. Okay.
Yep. So yeah. So when you think of those sensors, I always like to think of sensors as being your savior, really, right?
Yeah.
You know, it can be something that can really save you from having to get a whole nother robot if you figure out that your sensors are not kind of going along. But yeah, so we do have, so with this robotic arm, pretty much this is a very mechanical robotic arm. Is, you know, like I said, it all works strictly off of water. There's no like programming or anything like that. But the real thing that you can kind of detect here is you can pretty much detect. So it has two, I would say, hydraulic cylinders.
Okay,
much,
they
right?
can't really see all that in the shot too, by the way.
Yeah,
we want to make sure. But
so we have two hydraulic cylinders, right? So we have one that is going to have the water that's feeding in the water, and then we have one that's going to be feeding into the robotic arm, pretty much.
So it's almost like a gate, or like so like it goes into the hydraulic cylinders. Yeah. And that builds up pressure there a little bit.
Yep.
And so now that pressure can be transferred to the arm.
Yep.
And this right here. Oh. Sorry, chat. I got a little aggressive with the robot arm. But I think I can push that down in there, right?
Yeah, I think this.
There you go.
Yeah.
I got a little aggressive, chat. All right, here we go.
That has to go back in there.
But basically, what happens is the pressure for this particular robotic arm.
Be nice to the robot.
Sorry, yeah. Be nice to the robots if you want them to be nice to you. Do not.
No, that's so true, though.
Do not mess up. Do not mess with the robot. But the pressure controls this gripper too, so that influences how strong this clamp can make.
How strong it can
attach to whatever it's trying to pick up.
Yeah. So I mean, even when you think about like the hydraulics and the cylinders that we have, right? The amount of water that are actually in the cylinders can determine how much the pressure is of how the grippers are pretty much gripping and everything like that.
All right. I think I got the arm. Rich.
Yeah, you getting it, bro.
How y'all like me now? All right, we got the arm.
Yeah, you getting it.
So this will go right here.
Yep.
Is this in the way?
Nah, you good.
Did I turn it? Hold on. So this can turn. This arm should be able to turn. Oh, okay, I got it. So
there
like
are some
this.
screws that you got to put down there to pretty much
clamp it in.
But so we'll have to flip it over. But I'm gonna put this water in here and put these caps on there, and then we should be
Well, I think we are getting to some good. Might have to call in the army of interns. Y'all already know how it goes. But let me tell y'all really quick what we got going on. I am looking over here at the chat, but here's what we got going on, y'all. I'm gonna look to my camera here here's what we got going on for tomorrow. Tomorrow, as we get it going, we are going to have a chocolate welding exercise. We're gonna be dealing with inventions, and a lot of inventors out there. And I don't know about y'all, but when I was a kid, that was really the only STEM career I knew. Inventors, people that just made things, right? So we're gonna be talking about inventing tomorrow, and we're gonna be doing some chocolate welding. So we're gonna get busy. And then on Friday we have another virtual field trip with Trapology Boston. Y'all know our favorite people, our favorite escape room gurus are going to be joining us again on Friday. So make sure you stay tuned for that. Going to come back here. We got a few more. We need to wire up a siren. Do we need to see? I see Papa Sim over there. We stay tuned for sure. Adventures of Nipple. We see you on Tony. We see you, King James. Yes, we see y'all. Make sure you all please stay tuned for us. And if you haven't already, fill out the survey that we are dropping in the chat periodically so we can know how things are going. Rich, I don't want to
we probably need a funnel to put this water in.
Yeah. Let's hold off on the water right now because our time is moving here, and I want to make sure that people can really see what we got going on here.
Okay.
Because this right here is gonna attach to the clamps, right? How do the clamps attach to this, Rich?
So what?
How do the clamps attach to this?
Okay, so that's gonna be in a little later part.
Okay.
But pretty much it's gonna be one of the cylinders are gonna have.
Let's bring this over because I want to make sure.
So one of the cylinders are gonna have an attachment Pretty much that's going to allow you to then place that in this part right here, and then you'll be able to close the clamp, and then the grippers will kind of attach from there.
I'm gonna get the overhead so people can see here, because we have what we're almost done with, which we're probably not gonna finish here in a second, but it's gonna eventually be like this. You're gonna put the reservoir into here, okay?
Yeah. Good.
Got it.
It's in here. Then wait, where'd my book go?
Your instructions. Here, you can grab this one.
Lost it.
I got my arm done, y'all. I got my arm nice and ready to go. DuckTales. Shout out to the ghost hand that came out of nowhere. Joe, that's you, Joe. That's you, Joe. All right. Yes, tell us about your experience. Thank you, Noah, for dropping that again in the chat. But let's make sure we explain to everybody, Rich, because I don't know if again, people might have some opportunities to do this on their own in the future when this drops.
Yeah.
But let's go ahead and show them the correlation of what the next steps would be in this process. All right.
Yeah.
So we got this reservoir here. How does the water even come out of it? Is it here?
Yeah. So the water is all going to pretty much, there's tubing that we're about to set up as well. So the water is all going to be connected from the different hydraulic cylinders and the tubing that are all going to pretty much connect, to this back part.
All right. So then the tubing, well, I guess I don't quite still see. So tubing is going to come from here, or something under here going to connect to this syringe.
So pretty much, my bad.
So we're right here. So I'm looking at this one right here. There's another syringe here on this finished one.
Right.
That connects under here.
Yeah. It's going to connect. It's pretty much going to kind of connect from the bottom of it.
From the bottom of it.
Yeah.
It's going to pull water into this sort of syringe area right here.
Yeah, it's going to pull water from that syringe, and then it's going to pull and go directly into the arm, then which will control it to pretty much move.
So I see that these have multiple. What are all these different controls for though? Like, why do we have so many?
Yeah. So different. They'll pretty much control different parts of the arm to pretty much move.
Oh, okay.
So so we have what is it? It's just a C1 through 5. So you can look at them like different joysticks, different levels
of different joints.
Yeah,
so
different joints.
One open and closes one joint, another open and closes. Kind of like if you're operating like a forklift or a crane or something like that.
I mean, that's kind of like the thing about like hydraulic power, right? You can kind of relate it to that same part of like just that mechanical energy, but now the water is acting as that mechanism to really control everything.
Got it. Well, man, this has been cool. So now back to again your work. Really do. Well, no, back to you. I want to ask you some more questions because in reality, Rich, I don't think we're going to be done. So we're gonna be it's getting pretty close to our time. So let me ask you more questions about your work too, though, as it relates to automation engineer. What are some of the things that you see the future for your line of work that people who are maybe interested in like creating or doing things of this nature in the field might want to look into?
Yeah, I mean, well, in robotics in general, a lot of things are going into the automated route, right? So, me in particular, I've worked in biotech for the past 5 years, but there's also things, the restaurant industry is starting to have a lot of automation. So there's restaurants now that have like robots that are like
cooking,
I think it's a McDonald's somewhere that has like robots that are like building everything, right? So I'll say there's a lot of industries that are looking to, honestly, anything like when I like to look at it as a framework of like anything that you think anything that can have something that can save time, it can have
through
robotics.
like a repetitive action.
Repetitive nature. You can have robotics kind of built around that.
Yeah. And then when you have AI, when you include AI in the software, now you're having obviously the machine learning oftentimes is referred to it in the software, sort of learning through data sets, whatever. But you can have machine learning in the actual machinery of a robot. Through the software. So the stuff that you're doing as an automation engineer, would you say that some of that will perhaps go to sort of an AI functionality as well? Or is the stuff you're doing in the lab still sort of like that?
So I would say it depends on what industry you're in, right? So I know for me in particular within biotech, AI can be used. I mean, I use AI from different things of like maybe like helping me, put together figuring out how many errors might have occurred on a certain robot. So now I could kind of come up with emphasis on like, oh, this robot may, need maintenance from a vendor or something, or a PM or something.
Okay.
But from the aspect of like, far as like automation, I feel like even though, a lot of things are being automated, there's still that person that kind of needs to be there to have that understanding of like certain aspects.
Right.
So we're not fully there yet.
Yeah, we're not fully there yet.
Question. Yeah,
I love it.
Fully there yet.
All right, cool. Hey, y'all, I'm gonna ask Rich here in just a second to give us some parting words of wisdom. But again, this is a robotics arm.
We had time already.
For sure. That's what I was telling you. Like, yeah, I see you looking. I was like, Rich, we're gonna knock this out. We're gonna take this to ICU off camera.
We're gonna have a part 2.
Yeah, but again, I'm gonna ask you a little bit. You can give some parting words of wisdom. But again, I want you all to know this is a type of robotic arm. This one's powered by hydraulics. Obviously, there are probably other ones that's like electromechanical and things of that nature. Yeah. Different types of power. This thing gets really, really advanced. It gets really, really advanced. But an activity like this can allow a person to kind of get an idea of sort of the functionality of how these things operate, how we want to physically position them to whether it's moving, something that is, dangerous or something that's expensive or whatever the case may be through a repetitive process. So we encourage you all, for those of you all who are interested in this, those of you all who have young folks or even yourself that wants to get more and more involved in sort of this process, get a hold of something like this and try it out. But Rich, what is your parting words of wisdom from the folks?
Really my parting words of
you can tell it
okay.
Right.
Looking at the camera right here. No, I really will say your imagination is the biggest nation. That's kind of my quote that I live my life by.
Yeah.
Really, if you can imagine something, you can really do it, right? And even with as we're here building with robotics and just diving in, having fun within STEM, and your platform is amazing. I watched a lot of your episodes. STEM is life, right? STEM is life. Science is life. Engineering is life. It's all around us. And there's amazing things that we can do and have fun and really, continue to build the world in an innovative way. So yeah, that's my words of motion. I would say, your imagination is the biggest nation.
Imagination is the biggest nation. Y'all show some love, chat. Show some love. I'm going here. Drop in the chat. Let's thank Rich. Yes, right. This thing, we already had the whole series of because this is just one component. But if you were to build,
this is actually like a like where STEM Plug is looking in a new year of having month-long programs where we're building this thing out.
So this is going to be monthly programs and stuff.
Yeah. Because there's a lot of activities that kind of goes into it, and then also like helping kids see where you can realistically take this robot and allow kids to actually use their creativity in their mind, right? So I'm someone that I write books and I put out different things, but I also like to challenge kids to see where they think they can take things, right? So as a child, or if there's any parents in the chat or anything, ask your kids, like, when you see a robot, what do you think it can do? Right? You don't have to tell them what it'll do. Ask them what they think it could do.
What they think it could do.
So help them kind of, bring that mind going.
Explore the
that.
Biggest nation. Imagination. Yeah. There it is, our layout again for what we got going on the rest of the week. I want to thank you all so much for hanging out with us today. Make sure you come back tomorrow. We're going to be doing some more hands-on stuff. It might be a little messy too, because we indeed have some welding that's taking place with chocolate. But with that being said, thank y'all for hanging out. We got to, of course, take this a little bit more into ICU so we can get things done. With that being said, I hope you all take care. It's all trial and error. I hope this show again has given you all sort of the confidence to say, hey, let's see if it works out. Let's give it a go. Because at the end of the day, we're in an ever-ending engineering design cycle. And so no matter what's going on with y'all, make sure you keep building. And I'll see you next time. Peace.